Good evening, sir.
Good evening, everyone. Good evening, Beta.
Good evening, sir.
Good evening. Good evening. Just 1 minute. We're gonna start the class.
Good evening, sir.
Good evening. Good evening.
Good evening, sir.
Good evening, all of you. I hope my voice is loud and clear to everyone.
Yes, sir.
Yes.
Yeah. Just 1 minute. Let others join. We'll start it. Actually, I will start the class with a PYQ question which I have given before the holidays. Okay. Yes. Day before yesterday when the class got over now, I think Shri and one more girl asked that question to me personally on WhatsApp. So I thought that maybe I should discuss. So that question, you can get it in your group PDF there. I'll tell you what is the question. It says that when the temperature increased by from 0 to 10 degree, the length of the wire is increased by 0.02%. So they are asking percentage change in density. This is what they're asking. Okay, this is I think 2020 PYQ question. Shri, that was the question.
Yes, sir. The percentage change in must.
Okay, I would like to know, have you guys done error till now? Error calculation? In physics, have you done unit measurement and errors?
No, sir.
No, sir. No, sir.
Okay, so what I'm going to tell you is related a bit related to errors. So please, for time being, just try to understand as much as you can. But I'm assuring you, the moment I will take the topic, and I will take it very soon, these kind of questions will become very easy for you all. Okay? Look, here what we have to do is, first thing is delta L equals to alpha L delta T, and delta L by L for us is given as 0.02%, right? This information is given. So that means this value is what? Alpha delta T. Is that clear? Now, if we know alpha delta T, can we also calculate 2 alpha delta T? 2 alpha delta T will become 0.04% just by multiplying 2 on both sides, right? Now, what does 2 alpha means? 2 alpha means beta delta T. So beta delta T is 0.04%. And beta delta T, if you remember, is nothing but delta A by A means change in area percentage. Is this point clear to all of you?
Yes, sir.
Is that making sense? That for us, percentage change in length, Bhavesh, your answer is correct, beta. For us, percentage change in length given. So from percentage change in length, I calculated the percentage change in area by doubling it. Right? Now, they want density change, percentage change in density. Now, error formula or error rule says that density formula is mass upon volume. And this part I will explain you properly or to all of you when we do unit measurement and errors. But as of now, I think you'll all understand. So the error of density will depend on mass and it will depend on volume. Now, mass is fine. What is volume? Area into length. Now, mass is constant. So because there is no change in mass given. So we will take mass as constant. If it is not mentioned that mass is changing, so we have to take mass as constant. Now, can I say that change in density is only depending on change in area or error of area or error of length? Is this point clear to all of you? Please let me know. Because mass is constant, there is no change in mass. So only there is an error in area and there is an error in length. So these two will decide how much will be the error in density.
Yes,
Is
sir.
this point is making sense to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
I'm not just explaining to Shri or one or two students, I'm explaining to all of you. That's why I've taken this question in class. I would have also explained her in the on the WhatsApp itself, the same thing. Are we clear with this? Now, what is the percentage change or percentage error in area? 0.04. And what is the percentage error in length? 0.02. So can I say the percentage error in density will be 0.06%? Shri, this is the answer, beta.
Okay, sir. Got it now. Thank
Sir,
you, sir.
excuse me.
Yes, beta.
Sir, can we do this by finding the volume expansion for a solid?
Yes, you will take 3 times, and that is also correct.
So like we will take afterwards mass as constant.
Yeah, I got your point. You will take 0.02 in equals size will get gamma, right?
Yes, sir.
Yes, Bhavesh, the only reason why I took volume as area into length, I didn't want to assume it like a cube. Okay, that was the only reason. But what you said is totally fine. We can get answer from that also.
Okay, sir.
Okay, guys. So let's come back to the topic which we were doing in the previous class. That was the question. And I would welcome all your doubts on my WhatsApp number. Please share it. If it is, I'll find it very relevant, I will take it in the class, or else I will clear it in the group itself or on the WhatsApp itself. Clear? So don't hesitate in asking doubts, whether it's an advanced question, mains question, your book question, anywhere you're getting any problem, you can share with me. Is that clear to all of you?
Yes, sir. Yes.
Keep trying the questions and I am there to help you out. Don't rely on only on the classes. You can ask me anytime. If I'm busy, I'll tell you that I'll revert you back. Max to max, that will happen. Okay. So in the previous class, we done a question where ice we mixed with water, right? We did that question. Now I want all of you to understand, if suppose we are mixing steam with water or ice, steam with water or ice. So here what we should do, if it is water, we will take water up to which temperature? 100 degrees Celsius. If it is ice, we will first melt it. And once it got melted, we will assume that it will go up to 100 degrees Celsius. What we are going to do here is, we will calculate how much heat water will consume or ice will consume during melting and then boiling up to 100 degree. We will find out this heat received because it will receive from steam, and we will here calculate heat lost. Now, assuming that heat loss is equivalent to heat Q received, in that case, all the steam will condense into water at 100 degree. If Q lost means what steam is giving is quite more than what water is required to come up to 100 degrees Celsius, then in that case, some part of steam will still left uncondensed and some part of the steam will condense into water. Is that point clear to all of you, what I said about the concept of steam mixing with water or ice?
Yes, sir.
So we have to do a basic calculation, and based on calculation, we have to see whether how much part of steam has converted into water or condensed into water, or how much part of steam is still left, right? So our reference temperature in case of steam mixing with any these of two will be 100 degree. Okay, shall we take a question based on this? Because I don't think in the previous class we have taken any question where steam was getting mixed, right?
Yes, sir.
Yes, sir.
So can you please explain it once more?
Yeah, sure. What I said, Pavneet, ki if we are mixing with steam with any of ice or water, let's say, right? So what we will do, obviously the water or ice at a lower temperature, they will receive heat, and steam being at higher energy will lose heat, right? So when steam will lose heat at 100 degree, it will condense. And how much heat it will lose? Mass into latent heat of vaporization during condensation, right? That heat will be received by water or ice. So we will do the calculation of how much heat is required for X amount of water to come up to 100 degrees Celsius by using the formula mass into specific heat into delta T. Or if it is ice, then first the ice will melt and then it will come up to 100 degrees Celsius. So we will calculate how much heat is required. And steam is losing the heat. So we will calculate what is the mass of steam available into latent heat of vaporization. So if they are exactly equal, so we will say that all the water will boil up to 100 degree and steam will all condense into water. But if there are more than sufficient steam available, then may not be all the steam will condense into water. Some will condense and some will still remain steam at 100 degrees Celsius. Is that clear now, Pavneet?
Yes, sir.
Okay. So guys, I'm taking the question. I'm sharing the question on your screen instead of writing it because it will take more time. So is it visible to all of you 22.5?
Yes, sir. Yes.
Bhavesh, correct. Good. So everyone, I'm giving 1 more minute. So please, because I know most of you are almost on the verge of getting the answer. Please send it to me. After that, I'll take it on the whiteboard. Shri Betak. Shri, what answer you have given is that one is condensed steam, na?
So condensed steam.
Okay, no, the
Is
steam
this
which
the-
is left.
Yes, yes, sir. And I have taken 540 to make the
Yeah,
calculation.
surely that is fine. But during J exam, just pay attention on the value they have given.
Yes, yes, sir. I know, but here to make
Most
it
probably
fast.
it will be 540 only, what I have seen so far in the papers. Yeah, beta, correct. Come on, others also, please hurry up. All right, let me take this because I want to discuss more questions. So there is a limit of time I can provide. But anyway, I'm sure many of you are on the verge. Gaurangi, correct, beta. Aditya, slightly off from the answer, but I think you have rounded off. That's why you're getting it.
Yes,
Okay.
sir, I rounded.
Yeah, sure. I got it from. So everyone, here we will see that Q received or Q required, whatever you want to say, for water to rise up to 100 degree, right? So there is 200 gram of water, if I'm not wrong, 1 calorie per gram per degree Celsius, and from 40 they are going to 100. So simple. This will be 12,000 calories, right? So this is the amount of heat required by the water to rise up to water from 40 degree to rise up to 100 degree. Who will going to provide this heat? Obviously steam. How much mass of steam will condense? Let's say the M mass of steam will condense. So M into latent heat of vaporization, you just compare with 12,000 calorie. Now, I think LV is given as 539, but I prefer 540. So it won't going to make much difference. So this approximately coming as 22.2 gram. Right? 22.2 or 22.3 will be the answer. So that means this much mass of steam is condensed. This is a steam condensed into water. So what is my final? I have already, I have some steam left. So my final temperature is 100 degrees Celsius. Finally, 200 plus 22. So this is the amount of water I will have in the final composition. And obviously, 22.2, so 7.8 gram of steam I will have in the final composition. Is these answers are clear to all of you? Please give me a thumbs up, everyone. And if anyone having any doubt, please ask. Are we clear with this fast? So that I can move to the next problem. Everyone clear?
Yes.
Okay.
Yes, sir.
So let me take another question. Acha, before I go to another problem, let me again give you a small conceptual thing called water equivalent. Actually, nowadays it becomes very important, this part.
Sir,
Yes, Aditya?
sir, in the last class you had given us a question to think about why for water latency
Yeah,
is more
yeah.
for
Thanks for
vaporization.
reminding me. I'll come to that at the end of the class. Why this latent heat of fusion is less as compared to latent heat of vaporization. Have you guys go through the answer? I'll come to that part. First, let me clear this water equivalent. Okay. So please try to understand what is the meaning of water equivalent. Suppose we have a container, and in this container, we have, let's say, 90 gram of mass water, and I am heating the container. The container have some mass of its own. Let's say mass of container is mc, and the specific heat of container is something. Specific heat is Sc. Okay. Now, water, let's say the rise in temperature here is 50 degrees Celsius. Now, guys, tell me one thing. How much of heat I will required to rise the temperature by 50 degrees Celsius? Please give me the answer. Specific heat of water is 1 calorie per gram per degree Celsius. How much is the heat required here?
So heat required to vaporize the water.
Heat required to heat up the water.
Okay.
Oh. Just think and answer. You
Sir,
guys
is it 4500?
should be 4500 under ideal case, but
Yes.
do you really think that I will give that question? Varangi?
Oh, sorry, sir. I forgot about the container.
Yes. Shri, you understood why I've given this question?
Yes, yes, sir.
I
After that, you
know.
asked to raise temperature of water, so I thought only the water part. That's why I said.
Arey Baba, container will also get heat up, no?
Yes, yes, sir. I'm sending that.
Huh. Guys, let me give you the answer. The
Was
answer
the
is,
delta T is 50 degrees Celsius?
yeah, that is the rise of temperature.
Okay.
The answer here will not be 4500 calorie, which some of you might have calculated. 4500 calorie will be our answer when there is no mass of container given to us, or there is nothing about container is mentioned in the question. Are you getting my point? In the previous class, I have not mentioned the mass of container even once. So at that point, ms delta T, which gives you 90 into 1 into 50, will give you 4500 calorie, is perfectly fine answer. But here, since I have mentioned the mass of container and specific heat of container, so one thing you should realize that here, whatever heat, whatever answer will be there, it should be more than 4500 calorie. Why? Because 4500 calorie the only water will take. And you have container also which is absorbing heat. So the answer which you should come up with is mass of container into specific heat of container into delta T plus 4500 calorie. Is that part clear to all of you? Is that clear to everyone what I have written over here?
Yes,
Because conceptually you should be clear that why I'm discussing this. if in question, let's say in a JEE question, you have mass of container, specific heat of container, you should understand what is the use of that. Everyone, are we clear with this Q required, and are we clear why it is not equal to 4500? Give me a thumbs up fast. All of you. Clear? Okay, guys. Now let me tell you what is the meaning of water equivalent. So we understood this is the extra heat we want. This heat is not going to water, this is going for container. If I take this Q extra and I will equate with mass of water, I will equate with what? Mass of water into specific heat of water for same rise as the rise of container, for same rise. Basically what I'm doing is, let's say container is absorbing 500 calorie. So I am comparing this 500 calorie by some mass of water into specific heat of water into delta T. From there, I will get a relation. Mass of container, specific heat of container, delta T will be gone, equals to equivalent mass, specific heat of water. What is this? This means whatever container is absorbing, if it is given to water, this much extra mass of water could have been boiled to the same rise of temperature. So this is called water equivalent. Means if I say that a container having water equivalent of 10 gram, because that will be mentioned in the lab, it means how much heat container is going to absorb. It is same as the heat absorbed by 10 gram of water if it is boiled to a delta T rise of temperature. Is this clear what I have said about the water equivalent?
Yes, sir.
Yes.
Everyone, is this point
Please
clear to
explain
you?
that thing again.
Yeah, I will. I know that some of you may not have got it in the first go. Let me again reframe it what I said. What I said is extra heat absorbed by container is how much? Mass of container, specific heat of container, delta T. We are comparing this extra heat with some amount of water, equivalent amount of water, if it is given to water instead of container. So what we will refer to, instead of using mass of container, specific heat of container, we will use water equivalent. Let's say water equivalent is 10 gram. So what you will do, instead of taking MCSC for container, you will take 10 gram into 1 calorie. Now it is making sense to all of you. And this will give you what? This will give you the heat absorbed by container, heat consumed by container for delta T rise of temperature. Is this point clear to all of you? Now, that by using water equivalent, indirectly we are using the mass and specific heat of a container. Because water equivalent is the equivalent heat if given to some mass of water, it will boil to same rise of temperature. Let me give you one more example so that you will have a better clarity of water equivalent. For example, I have a container. In this container, I'm having a mass of water. How much mass of water? 95 gram of water. And for container, water equivalent is given as 5 gram. I want to rise the temperature by 20 degree. Guys, should I take 95 gram or should I take 100 gram total mass?
100 gram.
100 grams.
All of you, should we take 100 gram?
100 gram.
Or now in 100 gram, 95 is going to water and 5 gram of heat is going where?
To the container.
To the
To
container.
Yes, to the container. That is the application of water equivalent. So here we will write 95 plus 5 into 1 into 20. Let's say if water equivalent is not mentioned, mass and specific heat of container mentioned, fine, we will use that. But we should understand in both case scenario how to get the total heat. So wait, 20. So how much you'll get? 100 into 20. Is that clear to all of you now? This water equivalent concept? Tell me fast.
Yes, sir.
Yes, sir.
All
Yes,
of you
sir.
conceptually?
Excuse
Okay.
me, sir.
Yes, beta?
Sir, can we use the same formula to find like equivalent mass of different liquids also other than water?
Yeah, we can do that. For that, we will use container mass or specific heat of container or water with any other mass and specific heat. We can do that.
Okay, sir.
We can make any type of question. It's just we are comparing the energies, right? For the same rise.
Yes.
Okay. Aditya, clear, beta?
Yes, sir.
All right. So now let me take another question. Just wait. From here only I'll take. All of you can see this JEE 2006 question.
Yes, sir.
Yes.
Is this visible to all of you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now I'll tell you JEE means not JEE means. It's a IIT advanced subjective question. Okay. So please go through it. Please try to solve this question. Here also you have to do the calculation. Bhavesh, correct better. Isabel, correct. Good. Bhavesh, your answer is correct. Gaurangi, final temperature, just check. Ice will first come to 0 degree, then it will melt. Melting will happen only at 0 degree. Yeah, Isabel, what is your acha composition you are saying? That's correct.
Yes, sir.
Yeah, fine. Aditya, I don't think that is the answer. Please check. Okay, let me take this now. I think I have given enough time. Here, just by looking at the data, one can make a guess that since ice is quite large as compared to steam, so there might be a chance that they can come only up to melting point. Anyway, so we have 0.05 kg of steam at at 100 degree, 373 Kelvin is that only. And we have ice at 0.45 kg of ice at 253 Kelvin. So 253 Kelvin means minus 20 degree. Correct? So I will first calculate how much heat will be lost by steam. So heat lost by steam. Now please make sure those who are still solving that you also going through the same process. So first of all, steam will condense into water, right? Steam will condense into water at 100 degree Celsius. So it will lose Q1 heat, and this Q1 is nothing but 0.05 into latent heat of vaporization, which is given as if you want to calculate in calorie, you will get 540. So I think for that you'll have to convert the mass in gram. So you'll get 27,000 calories, right? And then water will come further down to water at 0 degree, and here also it will lose heat, which is 50 into 1 into 100. So this is also 5,000. Now total heat loss by steam coming to water and then water to 0 degree is 27,000 plus 5,000. So 27,000 plus 5,000 or 27 plus 5 will be 32 kilocalorie. Right. Now let's see how much ice will melt from this. So first of all, ice from minus 20 degree will come to ice at 0 degree. For this, it will require some Q3 heat, and then it will melt into water. So this Q3 will be mass of ice, which is 540, into specific heat of ice, which is 0.5 into. So this is 4,500 calorie. And for melting, it will require Q4, which is 540 into 80. And this will be 36,000 calorie. Now, everyone, are we clear with these calculations? How I got 27,000, how I got 5,000, how I got 4,500 calorie, how I got 36,000 calorie. It is quite evident to melt completely, the required amount of heat is 36 and 4.5. So that will make it 41.5 kilocalorie. And how much steam can give? it can give only 32. So there is a deficit. Q required is more than Q lost or Q available. So what will happen? Will all ice will melt? Only partial ice will melt, and some of the ice will still remain in same form at 0 degrees Celsius. What should be our answer?
The partial ice will melt and final temperature 0 degrees Celsius.
Yeah, final temperature, because ice is coming to 0 degree and steam converting into water, it is coming down to 0 degree. So our answer for this question is 0 degree or 273 Kelvin. Same type of question JEE people can ask, that what amount of ice melted. So for that, it's very simple to calculate. You have how much kilocalorie? 32 kilocalorie. Out of that 32, 4.5 kilocalorie ice is used to come up to 0 degree. So from 32, you just remove 4.5. So for melting, how much is available? 32 minus 4.5. Is that clear to all of you? This is 27.5 kilocalorie, and simply mass of ice melted, you can say 27.5 divided by 80, you can convert it into.
Sir, but we should convert 27.5 into calories, sir.
Yeah, 27.5 is in kilocalorie, no? So that's what I'm telling. You can just multiply 1000.
But yeah.
So you will get 343.7 gram as the mass of ice melted into water. Is that last point? It was not asked, but I can say that this could be the question in your JEE exam. So are we clear with that part also?
So can you
Yes.
explain why mass of melted ice is 27.5 divided by 80?
Yeah, sure, beta. Gaurangi, tell me one thing. I'm using you because others will also understand in that way. How much heat we have, how much heat is available for ice to come up to 0 degree and then melt? 32 kilocalorie, right?
Yes.
And out of those 32, 4.5 kilocalorie, this part, is utilized by ice to first come to 0 degree Celsius. Because ice is at not 0 degree, no, it is at minus 20. So from minus 20, it will first rise up to 0 degree. Isn't it? So 32, you have to subtract 4.5 kilocalorie, because that part is not utilized for melting. It is utilized to raise the temperature of ice from minus 20 to 0. Isn't it?
Yes.
So 32 minus 4.5 is how much left?
27.5.
27.5, exactly. Now 27.5 is in kilocalorie, so we have to multiply 1000 to get the mass in gram. So 27 into 1000 divided by 80. 80 is the latent heat of fusion, right? In calorie. So that will give us how much mass melted? 343.7. Are we clear now?
Yes, sir.
Okay. Everyone else, are we clear with this?
Yes, sir.
Yes, sir.
All right. So let me take one more question. Sweet. All of you, can you see that question number 5, which came in JEE 1996? Is it visible to all of you?
Yes, sir.
Just go for that question. those who got disconnected in between, just go for question number 5 visible on your screen. Bhavesh, correct, beta. Isabel, correct. Aradhya, correct. Shri, correct, beta. Good. Gaurangi, correct, beta. Good. Please use the data which is either given above or I already mentioned for vaporization and all. No, Aditya, check your answer, beta. Arinja, correct. Yuvraj, check your answer, beta. Okay, let me take this now on the whiteboard. Question is very simple. How much mass of steam is required to rise the temperature of water from 24 to 90? So here we will say that heat lost by steam equals to heat gained by water. Now just keep one thing in mind. It's not only steam is condensed, they are deliberately given 90 degree to make student commit a mistake that the student only takes the condensation. Do not consider that steam will convert into water and it will further come down to 90 degree, right? So that was the only part where you have to be careful. So let's say the m mass of steam converted. So how much steam heat it will lose? Mass into latent heat of vaporization, and the same mass into 1 into delta T. How much is delta T? 10 degree. From 100 it will come down to 90. This is the total heat lost by steam. And heat gained by water, how much was the mass of the water? 100. So 100 into 1 into 90 minus 24. Just calculate, you'll get the value of LV, you take it as 540. Calculate, you'll get the value of M, which will be around 12.2 or 3 something. Are we clear with this, everyone? What I have written over here?
Yes.
Most importantly, those who didn't get the answer. Aditya, beta clear?
Yeah, sir, I got it.
Okay. Yuvraj, clear, beta?
Yes, sir.
Yes. Okay. All right. So I will send some more question. There are a few more questions in the exercise. I'll send it. We are almost done with this. In the next class, I will take some PYQs, recent PYQs on calorimetry, and then we will move towards heat transfer. Is that clear to all of you?
Yes,
Yes.
sir. What
Yes,
about
sir.
that question you gave?
Yeah, thanks for reminding. Yeah, let's quickly, we have 2 minutes. Let's quickly discuss why the latent heat of vaporization is much more than latent heat of fusion. Actually, Bhavesh has sent one answer and it's pretty much correct what he sent. But I want to hear from some of you that have you searched for it? Actually, let me give the explanation, and it was pretty much in line with what Bhavesh has written. And I'm pretty sure that many of you also got the same explanation. When we are melting the ice, right? There are few things which is happening. There are hydrogen bonds also, which is there inside water, right? Ice is a cage-like structure. So these are the basic few reasons why ice density of water, instead of increasing, it decreases at sorry, it increases up to 4 degree and then it start decreasing, right? Because of the cage-like structure and all. So when melting is taking place, the molecules, or we are not breaking the bonds, basically. We are just making them slightly go away from each other from solid state to liquid state. Whereas when we are doing the boiling, we are almost making them go infinite distance apart from each other. Is that point clear to all of you? During gaseous state, the molecules will be at an infinite distance from each other, whereas in liquid state, they won't be at that far. So in which case we will require more heat or more energy when we will melt the water or when we will boil the water. When we make the molecules go slightly away from each other, or when we will make them completely break and go away infinitely from each other, in which case we will require more heat.
Completely
case.
break them and make them go away at infinite distance.
That is what we are doing for vaporization.
Boiling, for boiling, it will require higher.
Yeah, that is what we are doing at vaporization, and just slightly moving away from each other or making the intermolecular forces slightly lesser is what we are doing in during melting. Is that clear to all of you?
Yes, sir.
Yes.
Everyone, are we clear?
Yes, sir.
Yes, sir.
All right. So just like this, in classes to come, I'll keep giving questions like this, which will make your concept even more stronger. Anyway, we are doing questions and derivations in the class, but these type of conceptual questions will help in long run. Okay. Thanks, everyone. I hope this
Sir,
topic. Yeah. Yeah,
Sir,
Varun.
I have sent a question to you in a WhatsApp. Can you please tell me after this class?
Yeah, sure. I will revert back. Okay.
Sir, can you also teach relative motion because I didn't understand it and it was there in the first chapter?
Relative motion in 1D.
Yes, sir.
Yes, sir.
I will take it, beta. I will see. I wanted to finish this part, heat transfer. Once I will done with that, relative motion in 1D, relative motion in 2D, projectile motion, especially on collision problems and inclined motion problems, inclined projectile problems, I will take everything in the session. Is that clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Oh, okay. All right, everyone. I hope this concept and this chapter is making sense to all of you. Are you guys comfortable with this?
Yes, sir.
Yes, sir.
Okay, so from your side also, please solve the questions. And if you have any problem, just like Bhavesh, you can share with me. Okay. All right. See you tomorrow. And tomorrow, I'm not going to take any doubt class because we have just started. So we will solve questions on calorimetry and we'll try to start heat transfer. Is that fine to everyone?
Yes, sir.
Yes, sir.
Yeah.
Yes.
Maybe next week onwards,
Yes,
I'll
sir.
take the doubt classes. Fine. Okay. Chalo. See you tomorrow. Bye bye, everyone. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.